Sorry, I got cut in last video, and the software I'm using only allows me 15 minutes of recording. So sorry for the sudden cut. So on this slide, on the first part of this slide, I showed you guys the variance sum law, which we did in the previous slide. That is, the variance of the sum or difference of two independent variables is equal to the sum of their variances. So with this sampling distribution of the mean difference, next step we want to calculate the t-score for our observed mean differences. So we are back to this equation here, calculating the t-score. So we know the mean difference between these two samples. We know the population mean we want to compare with, which is actually 0, because we assume that the null hypothesis is true and there is no difference between mean and v-mean. And we also know this standard error of the sampling distribution. We have calculated this value in here. So this we want to plug in this cell, the value in this cell. So we plug in everything here, and this gives us the final answer of our t-score for our observed mean difference, which is 1.35. And the next step is we want to, compare this value against the values against the critical value we found in a t-table. So we know that we are doing a two-tailed test with a significance level of 0.05, and we still want to find one thing, which is the degree of freedom. This is a little bit tricky here. So how to calculate the degree of freedom for these two samples? Actually, the degree of freedom is decided by both sample size. So the overall of degree of freedom is the sum of the degree of freedom for each sample. Okay, so in our case, it is our month sample size minus 1. This part in the bracket is the degree of freedom for our month sample. And we want to also add up the degree of freedom for v-mean, that is the sample size of v-mean minus 1. Okay, so again, the degree of freedom for this t-test is the sum of the degree of freedoms for each sample. Okay, so here we have mean sample size 10 minus 1, the degree of freedom for mean, and same thing for the degree of freedom for v-mean. And this gives us the 20 as the degree of freedom for our independent t-test. And then we want to find the critical t-value for this degree of freedom of 20 at a significant level of 0.05 with a two-tailed test design. And we checked the t-table, and this critical t-value is positive and negative 2.086. And our obtained t-value is smaller than the absolute value of this critical t-value. So we say that we're going to return the null hypothesis because the probability of getting a score as large as this one is very likely. And get back to our example to the question, we say that there is no significant difference between mean and v-mean in terms of their lifetime sexual partner number. Okay, so the observed difference we got here, which is 2.32, is purely due to sampling error. It's an observation error, something due to chance. It's not a true difference here. Okay, so that is the whole procedure how we do an independent t-test, where we want to compare two separate sample or two separate groups, their mean, whether there is a significant or true difference existing between these two separate samples. And last step is we want to calculate the confidence limits. So we want to know the true difference between mean and v-mean in their sexual partner number based on the information we have, based on these two samples we have. So we identified with a degree of freedom of 20 and 95% confidence, the critical t-value here is positive and negative 2.086. This value we obtained it from the t-table. And then we want to do some algebra with this equation. We move this denominator to this side, and we also move this mean difference to this side. And we want to calculate this value here, right? So we plug kind of other numbers into this equation, and we know that this mean difference, the true mean difference, is falling somewhere between negative 1.72 and 5.91. So what does it mean? It means that based on the information we have, based on this data of these two samples we have, we infer that the difference between men's partner number and the women's partner number is somewhere between this negative 1.72 and 5.97. Okay, so for this part, it could mean that at most, women should have 1.72 more partners compared with men. And this side means that at most, men could have 5.91 more sexual partners than women. And the true mean difference is somewhere kind of between this limit and this limit. And please note that this limit bracket 0 here, right? So what does it mean? It means that it is possible that there is no true difference between women and men in terms of their sexual partner numbers throughout their lifetime. So that is this confidence limit here. So far, seems that we have got everything done. So since everything is done, and it's time for us to end the class, and it's time for a beer. But not really. Hold on. We have bad news again. I'm sorry. So remember, in our two samples, we have 10 men in one sample, 12 women in the other sample. So the difference between the sample size is not quite big. Okay. But if there is a big difference in terms of sample size between these two samples, we got a problem. So let's say we have 20 men in one sample, but 200 women in another sample. Okay, due to different reasons, probably 20 men is the best number, the most number we could recruit for this sample. Okay, there is a big difference in sample size between the two samples. So the way we estimate the standard error of the sampling distribution of the mean difference will not be accurate because we have this sample size very, very different from each other. We're going to use a different equation to estimate this part. I'm going to talk about it in next slide, and then I'll give you guys the practice for today's class, and then I'll talk about the R coding, and then that's all I have for today's class.